Good afternoon, class. In today's video, what I'd like to do is to go over the units, problem number 1 through 24. This is broken up into two different assignments in the miscellaneous section of the Google Classroom. However, what I wanted to do is to go over both of them because I figured it would have at least a little bit of it should look a little bit familiar in terms of the methods of solving these problems. So for numbers 1 through 10, the main tool or advice that I could give to you is to convert the derived units that you see in the assignment back from derived units into base units and then simplify. Once you simplify it, it should be a base unit and then you'll be good to go. So my example is number 1 in the units 1 through 10 problems, and that would be newtons times seconds squared per kilogram is going to be simplified into something. Now I want you to notice right over here, newtons times seconds squared, and see this slash over here? That's the only reason that I wrote it out like this was because when I created this document in Google Classroom, I could only type it out in one line, and that's the only way I could show the fraction bar. I don't really like this one because I know it tends to lead to a little bit of confusion. So what I would tell everybody is to rewrite this problem like I did over here, where I have newtons times seconds squared per kilogram, and I wrote it a little bit more like spread out like that. That's why, just so that it's a little bit easier to see what's going on. Then what we can do is say, okay, now that we've done that, we're left with now we can take the next step, which is to convert the derived unit, Newton, into base units, which is kilogram times meter per second squared. Notice that I've got second times second squared over kilograms. So when I can eliminate I can cross cancel all of these different units, simplifying them into meters. So that's the example from 1 through 10. Let's go through 11 through 24. In this one, I'm giving you a bunch of formulas. So in this case, so what you're going to do from there is you're going to take the variables, you're going to convert them into base units, because in the notes above all of these problems, I actually give you the conversion from variables to base units or from derived units to base units. So the example that I did was one of the ones where it says force times time squared divided by m, and don't forget this m over here means mass. So it kind of changes the unit. I know it's one of those cautions that we have to go through. M as a variable is kilograms because it's mass. M as a unit is meters, and it represents distance. So just want to make sure that that's kind of clear, because you're going to see M and then you're going to see M again. So we want to make sure we distinguish the two. With that, let's go into the example. So So first thing I do is I write this out, spread it out a little bit. Force times time squared over M, or mass. Then I convert all of my variables into derived units. So now I've got newtons times seconds squared per kilogram. Hopefully, you've started to notice that this looks kind of familiar, but we'll keep soldiering on right now. Newtons is a derived unit, and when it converted to base units, it's a kilogram times meter per second squared. Again, by multiplying by seconds squared over kilograms, because that's what we had earlier. And if you'll notice, kilograms cancels with kilograms because kilograms divided by kilograms is 1, like we did in our drill, and seconds squared divided by seconds squared is 1, like we did in our drill. What you're left with at the end is meters, right? So this m is a unit, this m is a variable. So that's where the conversion is. So that's something, hopefully that's a little quick example to show you. This is how you do units problems number 1 through 10, also 11 through 24. If there are any other, and so hopefully this is a good example that will show you what you need to do in order to solve all of these and do these conversions for units. So good luck in your studies, and may the force be with you.